Problem number 25. Integrate f of x, y, z is equal to z over the region with x squared plus y squared plus z squared is less than or equal to 9. X is greater than or equal to 0. Z is less than or equal to 0. We want to do this in spherical coordinates. Will be the easiest way to do that. How can we tell spherical coordinates? Because this is rho squared. So we have rho squared is less than or equal to 9. Rho is less than or equal to 3 here. As it turns out, there's not going to be any other bounds on rho here. So we know rho can never be negative. So our lower bound on rho will be 0. As for, let's see here, x. In the xy plane, we project this to the xy plane. We're going to have x be greater than or equal to 0. So it's the right half of the circle in the xy plane. This will show us that theta can run from negative pi over 2 to pi over 2. Okay, and then finally, z is less than or equal to 0. That's going to correspond to phi running from pi over 2 to pi. There's two ways to think about that. Z is rho cosine phi. So rho cosine phi is less than or equal to 0. We know rho isn't going to be negative, so cosine phi is going to be less than or equal to 0. And that's phi from pi over 2 to pi. Also, we project the region into, say, the yz plane. It's going to look like this region down here, and that's phi is 0, pi over 2 to pi. We pick up the region from pi over 2 to pi. Okay, so what do we have here? Okay, theta runs from negative pi over 2 to pi over 2. Phi runs from pi over 2 to pi. And rho runs from 0 to 3. Our integrand z becomes rho cosine phi. And then we throw in the factor of rho squared sine phi. That factor always comes in as the Jacobian for cylindrical, not cylindrical, but spherical coordinates transformation. D rho, d phi, d theta. Okay, so this is our integral. Let's evaluate it. Let's see here. I think this can factor all the way out. Theta is negative pi over 2 to pi over 2. D theta times phi is from pi over 2 to pi of cosine phi sine phi. D phi. And then our rho runs from 0 to 3. It looks like we have rho cubed d rho. Okay, what does this give us? This term will give us pi. For this term, let's see here, we can set u is equal to sine phi. And so then du will be cosine phi d phi. And so this integral becomes sine becomes u du when, let's see here, when phi is pi, sine pi is 0. When phi is pi over 2, sine of pi over 2 is 1. And then rho cubed becomes rho to the 4th for the antiderivative over 4. Plug in from 0 to 3. And so this will be pi. This will end up as negative 1/2. And this will end up as 3 to the 4th over 4. So there is our final answer.